In the year 2012, in their quest for world domination, the pirates set out to eliminate their only opposition by setting their sights on the best and brightest the world had to offer, Rutgers University. Their invasion was subtle at first, but then they made their presence known, and then chaos ensued. In the end, the fate of the world fell upon the shoulders of one, a lone fencer.
I challenge you to a duel.
For what?
For Rutgers.
Who are you?
The last thing you'll ever see.
And with what do you challenge me?
With this blade.
No! I challenge you with that blade. Fetch me my blade.
So you must be terribly curious as to how these absurd weapons, also known as foils, work. Do not fear, for I shall explain it to you, for these are weapons worthy of pirates.
The foil was designed to be easy to maneuver, flexible, and efficient at making attacks point first in a jabbing motion. A foil consists of three parts: the blade, the bell guard, and the grip. The first component to examine is the bell guard. The bell guard consists of a hemispherical piece of metal typically made out of steel, whose diameter ranges from 9.5 to 12 centimeters. This diameter was tailored to the bell guard's purpose, to protect the hand wielding the blade, approximating the length of a fist gripping the handle. This is so that if the opponent's sword travels down the blade, the shape of the bell guard will redirect the point away from the hand. The design of the handle serves to maximize maneuverability by enabling the movements of the blade to be controlled by minute pressure from the wrist and fingertips, while the remaining fingers support the weight of the blade. The fencing blade consists of a quadrangular piece of steel that tapers to a point. The blade is approximately 90 centimeters in length and consists of three portions: the forte, which is the thickest part of the blade and used for parrying or blocking, the middle that exchanges blows, and the foible that is the most susceptible to bending. The engineering behind the blade can be modeled by a cantilever beam, where the connection of the blade to the bell guard represents the fixed part of the beam. The blade experiences two types of loading. The first is axial compressive loading. This loading leads to the critical buckling load that the blade experiences, that is, how much force the blade can take along the axial direction until it buckles or bends upon impact with a target. It is governed by three main factors: the Young's modulus, for steel it is around 30 times 10 to the 6 psi, the moment of inertia, and the length of the blade. This explains the decision behind the length of the blade. If the blade is too long, it will buckle too easily. Too short, and the blade won't bend at all. The second type of loading is the bending stress, which leads to a tensile and compressive stress above and below the centroid of the blade. Bending stress is caused by moving the blade around too quickly or hitting with the side of the blade that causes the blade to bend. The bending stress depends on the bending moment, the distance from the centroid, and the moment of inertia.
Captain, I spilled your coffee!
The blade button component is located at the tip of the blade and consists of the point that receives the impact, the barrel that houses the components, the sleeve that holds the end of the point, and the pressure spring that connects the wire that runs throughout the blade. When the blade is plugged into a strip, there is a current running through the blade that creates a closed circuit. When the button is depressed, the insulator breaks the circuit to indicate that a point has been scored.
And thus, the pirates were defeated, and Rutgers saved.